This is the lesson for Algebra for 1-4. What we're going to be doing is creating our own graphs according to the function families today. So remember, these are the generic equations for each of the four function families that we can graph. We're not going to do the linear piecewise ones. So when we go to look at this, the linear function family, we have mx plus b, that x is always going to be there. For exponential function families, we have a times b to the x power, that x is always going to be there. For quadratic function family, we have ax squared plus bx plus c, the x squared is always going to be there, and the x. For the linear absolute value function family, we have the absolute value symbols, we have an x inside of there. So when we go to look at these, first we're going to characterize the different function families. So letter A says the graph of this function family is a smooth curve. So we're just looking for a curve to the graph, all right? The ones that would be a curve to the graph are the quadratic function family and the exponential. Let's take a look at those. The quadratic, again, we have a curve, and the exponential, we have a curve. So that's why those two work. For the graph of this function family is made up of one or more straight lines. Straight lines are going to be the linear and the absolute value function family. So let's take a look at those. The linear is a straight line, whether it goes up or down or straight across. The linear absolute value, it even has the word linear in it. Notice that it's made up of two straight lines because it is that V-shaped graph. This graph consists of, letter C, consists of increasing or decreasing over the entire domain. So this is increasing, or just decreasing. So over the entire domain. So linear is going up. Should be linear. This should be linear or exponential, not absolute value. So this should be exponential. So this is linear or exponential function families. We're just looking for just increasing or just decreasing over the entire domain. So just increasing is linear. It could go just up or it could go just down. Same thing with exponential. It can just go up or just go down. Then this one has a minimum or a maximum. That is quadratic or absolute value. So it has a maximum or a min. When we go to graph the quadratic, this would be an absolute min right here. It's the bottom part of the graph. This would be an absolute max. It would be the top part of the graph. For linear absolute value, this is the min part of the graph. This is the max part of the graph. It's the lowest point and the highest point on those graphs. So looking at these, we're trying to figure out exactly what function family it is. The graph of this function family has a min or max and is a smooth curve. So it has a max or a min and is a smooth curve. That would be the quadratic. If we take a look at quadratic, has a max or a min and is a smooth curve. All right, that is a smooth curve. Increases or decreases, so just increases or just decreases and is made up of a straight line, that is linear. Linear is just increasing or just decreasing and is a straight line. Smooth curve, so it's curved again and either just increases or just decreases, that is exponential. Smooth curve, it's curved and just increases or just decreases. This last one has an absolute min or max, has symmetry, and is made up of two straight lines. That's going to be your absolute value function family. Symmetry, we could draw a line, a vertical line going straight up here, and it would separate it into two equal pieces. Combination of increasing and decreasing has a maximum and a minimum. So this is the max, this is the min. It's the highest and lowest points, made up of two straight lines. So what you're going to have to do on your homework today is you're going to have to create your own graphs, all right? Now, when you go and do this, it's a little bit weird, all right? So we want this one. It is a function. It's exponential. That means we're going to have an exponent as an x. It's continuous and it's decreasing. Well, since it's decreasing, all right, first of all, we want the exponential function family. So we want an equation that looks like this, a times b to the x. So we're going to have our f of x, we're going to have our equal sign. In order for it to be decreasing, we need our a value to be negative. So I'm going to put in a -2. You can put it in any number you want for a, but in order for it to be going down, decreasing, we need a negative number there. So -2. And then I'm just going to choose 3 as my b. It doesn't really matter what I choose there. So when we go to graph it, you're going to type that into the calculator. All right, you're going to type it into your y equals. So y equals -2 times 3 caret button x. Go to second and then table to see your values. Table is the graph button in the upper right hand corner, but you have to hit the second button first. That gets us our points. Remember, when you graph points, your x value is how many we go over. Your y value is how many you go up or down. So when we go to graph our points, we're going to graph it. So -3 and -0.074. So we're going starting in the middle at 0, 0. We go over to -3, go down to -0.074. -2 and that, go over to -2, go down to that. -1 and -0.6. So that's about right there. 0 and -2 starting in the middle, over 0 down to -2, and then 1, -6, over to 1 down to -6. So it forms this graph, which is a function. It is exponential. It is continuous, so that's why we connected the dots, and it is decreasing. As we go from left to right, it is going down. Again, you could pick any numbers you want, but this negative number makes it go down. If this -2 was a positive number, then it would go up. So our next one that they want us to create has a minimum, is discrete, and is a linear absolute value function. So since it's linear absolute value function, we need to use the absolute value function family equation, which is this. So I'm just going to pick numbers, all right? I picked 1 as my a, all right? And then inside the absolute value symbol, all right? I didn't draw those in there, but this is what we would have there. We'd have our absolute value symbol there. So 1 times, and then inside the absolute value symbol, I have x plus 1, and then I have a plus 1 at the end. So when I go to look at it, it would look like this. So it's discrete. That's why we're not connecting the dots. All right, I go to type it into my y equals. Remember, you do your absolute value. You have to hit second and 0 to access the catalog, and then it's ABS and parentheses. And inside those parentheses, because we have the x plus 1, we would put x plus 1. So you would really type in 1 and then the time symbol, and then ABS, and then inside parentheses, x plus 1, and then you have your plus 1 at the end, which I forgot in here. So you would have this as your graph when you graph your points. It has a minimum. This is the bottom part. It is discrete. We're not connecting the dots, and it is part of the linear absolute value function family. For the next one, we want something that is linear, discrete, increasing, and a function. So that is part of the linear function family, which so we have f of x equals mx plus b. It's increasing, all right? So we want a positive number in front of our x. In this case, I didn't put a number, so that's really a 1 there. So f of x equals 1x plus 1. When you go to type it into your calculator, you hit second and table to get your points. When you go to graph it, it would look like this. We're not connecting the dots because it is discrete. If it was decreasing, we'd have to put a negative number in front of the x, but it's increasing, so that's why we have a positive number in front of the x. Over here, with the going back to the linear function, linear absolute value function, we have a minimum. If we wanted a maximum, we'd have to type in a negative number in front of the absolute value, so like a -1 here. For the next one, we want continuous, a maximum, a function, and is quadratic. So we want the quadratic function family. We can type in any numbers that we want for the a and the b, but the x squared and the x have to be there. We want a maximum, so I have to type in, because we have a maximum, I have to type in a negative number as my a. If it was a minimum, we'd have a positive number there. So typing in -2x squared plus 2x plus 1, these would be my points. And I would have this as my parabola. Creating a function that is, or an equation that is not a function, all right, what we have to remember here is something called hazy-vixen. All right, hazy-vixen is a way to graph horizontal and vertical lines. Hazy, the H in hazy stands for horizontal, and those are y equals equations. Anytime you have y equals a number, it's going to be a horizontal or straight across, left and right line. That doesn't go up or down, just goes straight across. Vixen, you're going to have an x equals equation, which is a vertical line. The V in Vixen stands for vertical. So because we want something that's not a function, we have to have an x equals equation. We can't put this into the calculator, all right? It would just be x equals 3. So all these points along here are x equals 3. This would be like 3, 0, 3, 1, 3, 2, 3, 3, 3, 4, 3, -1, 3, -2, 3 negative. So all of our x values are 3. And that would form our vertical line right here.